Hi everyone, this is your chemistry teacher Sir Naushad Mehdi, and in today's video we're going to solve some of the past paper questions which are from the topic of the organic chemistry from your past paper of May-June 2024. So let us start. This is the question number 2, and in this question it is saying that the aluminum carbide, the formula is given to you, reacts with the water to form methane and aluminium hydroxide. Construct the symbol equation for this reaction. Now if you want to convert a symbol equation, so there are two reactants which are given. Aluminium carbide reacts with water. So one of the reactant is aluminium carbide itself, and it is reacting with the water. So the formula of water you all know, H2O. So if I want to construct the equation, it would be like this: Al4C3 aluminium carbide plus H2O. Now these two reactants are reacting to form methane, CH4. So the formula is already given, CH4 plus and aluminium hydroxide. Now you have to construct the formula for aluminium hydroxide by your own, and you can construct this formula very easily by using the periodic table. And if you look at the periodic table, the position of aluminium, so aluminium you will find in the group 3 of the periodic table. So since it is in group 3, so it will have a charge of +3 on it. And when we are talking about the hydroxide, right? So hydroxide is basically the OH group. Alright, hydroxide means the OH group. So OH hydroxide has a charge of -1 on it. So you have to remember it about the charge. So when you will cross multiply the charges, so 3 will come below the OH in the subscript, and 1 will come in the subscript of the aluminium. So the final formula would be like this: okay, below aluminium you would be getting 1, so no need to write 1, Al, and below OH you have to write 3, so you have to place a bracket, because with the complete OH you are getting the 3 charge, 3 as a subscript. So this would be the formula for aluminium hydroxide. So this is the complete symbolic equation, but you also have to balance this equation also. So if you want to balance this equation, so here you can see that first of all, if you look at the aluminium on the reactant side, it's 4, Al4. But over here in the product we have just one aluminium. So if I want to balance this aluminium, so I will place 4 over here. So this will make aluminium 4. Now if you look at the carbon on the reactant side, so it's Al4C3. So there are 3 atoms of carbon. So if you want to balance the carbon, so you have to place 3 on this side. So it will make the carbon 3. Now just look for other elements, like for example, if you look for the hydrogen first, right? So on the reactant side we just have 2 hydrogens right now, but on the product side, if we count the hydrogens, first of all in CH4, 3 times 4 it becomes 12, and over here if you see, this 3 is with the hydrogen, so 3 times hydrogen over here, and this 4 will also multiply with the hydrogen also, right? So 4 times 3 becomes 12. So over here again we have the 12 hydrogens. So on the product side the total hydrogens would become 24. So there are total 24 hydrogens on the product side. So if you want to make 24 hydrogens on the reactant side, so simply you have to place 12 over here. So 12 times 2 will become 24. Now the last element which is left is oxygen, which is to be balanced. So first of all check it on the reactant side. 12 times 1 becomes 12 oxygen on the reactant side, and now look at the product side. So if you look at the product side, so in the product we have oxygen in aluminium hydroxide. So this 3 will multiply with this oxygen 3 times, and this 4 will also multiply with the oxygen. So 4 times 3 becomes 12. So 12 oxygen is on the product side, and 12 are on the reactant side also in the, if you look at the water. So this equation is now completely balanced, and this is your final answer for this question. Now moving towards the next question. Alright, so now in the next question it is saying that methane is a saturated hydrocarbon. Explain why methane is a hydrocarbon. Why methane is a hydrocarbon? So you all know that the formula for the methane is CH4. So why we are calling methane as a hydrocarbon? Because the CH4 is only made up of two elements, that is hydrogen and carbon. So hydrocarbon means the compound made up of hydrogen and carbon. So it is called as hydrocarbon because it contains only carbon and hydrogen. As you can see in the formula, it's CH4. Now in the next question it is saying explain why methane is saturated. So we have studied in the theory that there are two types of compounds, saturated and unsaturated. And the difference is that saturated compounds are those compounds in which all the bonds are your carbon-carbon bonds are your single covalent bonds, and there is not a single double or triple covalent bond in it. Alright, all the bonds are your single bonds. But when we talk about the unsaturated compounds, so in unsaturated compounds, all the carbon bonds are not the single bonds, and you must have at least one carbon-carbon double bond or at least one carbon-carbon triple bond. So that would be your unsaturated compound. But in comparison to saturated compound, all the bonds are your single covalent bonds. So we're going to write that methane contains all single covalent bonds. That's why we are calling it a saturated compound. Okay, now coming to the next question, it is saying methane reacts with chlorine in the presence of the ultraviolet light. So this is the basically this statement is referring to the halogenation reaction because we are reacting with the chlorine. So methane CH4 is reacting with the chlorine, and you all know that the formula of chlorine is in diatomic form, which is Cl2, in the presence of ultraviolet or sunlight. So when we talk about the halogenation reaction of alkane, which is methane right now, so you all know that it is a substitution reaction, and in the substitution reaction what happens, one of the halogen will get substituted with one of the hydrogen of this methane CH4. So you have to replace one of the hydrogen with one of the chlorine atom. So if you replace one of the hydrogen, so if you remove one of the hydrogen from CH4, so it will become CH3, and the hydrogen which you have removed is replaced by this chlorine atom, so it will become CH3Cl. And that hydrogen which is being replaced, right, for example, if I draw the structure over here, CH4 would be like this. So one of the hydrogen which you are replacing, so this one hydrogen is replaced by the chlorine, and it will come on this side and will combine with the another Cl to form the another product which would be your HCl, which would be the byproduct. So two products are formed. One of the product after the substitution of one of the hydrogen you are getting CH3Cl, and the another product which you are getting is your byproduct, which is your HCl. So these are the two products which will be formed. Okay, now coming to the next question. In the next question they are saying draw the dot and cross diagram to show the electronic configuration of methane. So you just have to draw the dot and cross diagram. So as we know, the formula of methane is CH4. So first of all you have to check the electronic arrangement and the atomic numbers from the periodic table. So atomic number of carbon is 6, so you will get 2, 4 electronic arrangement, and the atomic number of hydrogen is 1. So 1 is the electronic configuration of hydrogen. Now if you look at you just have to draw the outer shell electrons. So if you want to draw the outer shell electrons, in the outer shell of carbon you have 4 electrons. So obviously in CH4 carbon would be in the center because it's one single time. So if you place carbon in the center, so you have to place 4 electrons with the carbon. So 1, 2, 3, 4. So these are the outer shell electrons of carbon, right? Now you have to draw the hydrogen. Now hydrogen just have 1 electron in the last shell, and it's the first shell of hydrogen, so obviously it will be needing only 1 more electron to complete the last shell. So what hydrogen would be doing? It would be making a single covalent bond with the carbon. So there are 4 hydrogens in the formula. So all the 4 hydrogens will make a single covalent bond with the carbon atom, which is placed in the center. So this is the complete diagram of complete dotting cross diagram for the methane molecule. Alright, now we are heading towards our next question, question number 8, which is also from the topic of the organic chemistry from the same paper. Now in this question, they are giving you this type of flow chart, and you have to answer according to the scenario which is given in the question. So first of all, from here if we start, so it's saying butane-1-ol, right, is converting into an ester which is B by reacting it with ethanoic acid. Similarly, this compound A, which is butane-1-ol, is reacting with KMnO4 in the acidic medium H2SO4. So you all know that KMnO4 is an oxidizing agent, right? So what KMnO4 will do? It will oxidize the butanol into carboxylic acid. So as you can see, the part C is your carboxylic acid, right? And you can easily identify by looking at this part, which is COOH. Okay, so this COOH part would be your is identifying that this is your carboxylic acid. Similarly, then further this flow chart is continuing in a way that this C compound, which is carboxylic acid, is reacting with sodium carbonate. Similarly, this is reacting with NaOH also to give the product D and F, and it is then again reacting with this CH3CH2OH. So if you look at the formula CH3CH2OH, so OH means that it is an alcohol, and there are 2 carbon atoms, so it means you are reacting with ethanol. So this is your ethanol to give an ester G. Now let us solve the different parts. In the part A, it is saying draw the displayed formula of the compound A. Alright, so displayed formula is basically the formula which shows, in which you have to show the complete bond, whatever the bonds are present in that compound, you have to show all the complete bonds. So you have to show the displayed formula of the compound A, which is butane-1-ol. So butane-1-ol, so for example, first of all, if I want to write its molecular formula, right? So butane, the word but, right? But means 4 carbon atoms. So this but is giving me an idea that this butanol must be having 4 carbon atoms in it. So you must remember the journal formula of the homologous series of alcohols, which is this CnH2n plus 1 OH. So this is the journal formula for making the homologous series of alcohol. So if you put 4 in this formula, so it will become C4, and put 2n plus 1, put 4 over there, so you will be getting 9 OH. So this is the molecular formula of butane-1-ol. So you have to convert this molecular formula butane-1-ol into the displayed formula. So by looking at this formula, you're getting 4 carbon atoms, right? And all the carbon atoms will be having a single covalent bond. So 4 carbon atoms, and it is saying that the formula is butane-1-ol. So what is the meaning of this one? One means that you have to place the OH in this compound. So OH would be on the first carbon atom, right? So you have to number the carbon atoms. Either you start from the right corner or the left corner, it's up to you. So for example, if I start from numbering from the right corner, so it will be 1, 2, 3 and 4. So as the name is suggesting, butane-1-ol, so 1 means, so you have to place this OH on the first carbon atom, carbon number 1. So I am placing the OH on the first carbon atom, right? Now after placing this OH, you just have to simply put the hydrogens on all the carbon atoms according to the bonds which are left over. So if I start from the carbon number 1, so this carbon is making 2 bonds right now, one on the right with the OH and one on the left with the carbon. So carbon has a valency of 4. Carbon can make total 4 bonds in total. So this carbon is making 2 bonds right now, so I have to place 2 hydrogens over there. Similarly, if I look at the second carbon, so this carbon is also making 2 bonds right now. So 2 bonds are still left, so I have to place 2 hydrogens again. Third carbon is also making 2 bonds right now, so I have to place 2 hydrogens. And the fourth carbon is just making a single bond on the right side. So 3 bonds are still left, so I have to place 3 hydrogens over there. So if I count the total number of carbons, so there are 4, C4. If you count the total hydrogens except for this OH, so it would be 9, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and this one OH. So we are getting the formula C4H9OH. So this is the displayed formula of the compound A. Now coming to the next question, in the part B it is saying, state the name of an ester B. So whenever we talk about an ester formation, so you might be knowing that esters, how the esters are formed when you react an alcohol with the carboxylic acid. So when you react an alcohol with the carboxylic acid, so the product which is formed is your ester along with the formation of water molecule. So they are asking you to name an ester which is formed, which is your ester B. So over here it is your ester, right? So what you are doing, you are reacting the butanol, butanol with the ethanoic acid. Now I want to know the formula of ethanoic acid, right? So ethanoic acid means, okay, it is a carboxylic acid first of all, and the word eth means okay, there must be 2 carbon atoms in this carboxylic acid, right? So for 2 carbon atoms, if you look at the homologous series of carboxylic acid, so the homologous series is CnH2n plus 1 COOH. This is the homologous series journal formula for carboxylic acid. So ethanoic acid is suggesting me that it must be having 2 carbon atoms in it, right? The word eth is suggesting 2 carbon atoms. So 1 carbon atom is already there in COOH, right? So I need 1 more carbon. So what value of N I will put? I will put N equals to 1, because this COOH is already having 1 carbon in it. So it is very compulsory. This carbon is compulsory carbon which would be present in the carboxylic acid, COOH, right? So 1 carbon is already there, right? And I want total 2 carbon atoms. So I would put N equals to 1. So if I put N equals to 1, so it will become C1. If I put N over here 1 in 2n plus 1, so you'll be getting 2 multiplied by 1, 2 plus 1, 3. So you'll be getting CH3, COOH. So in CH3, COOH, you are getting 2 carbon atoms, 1 on CH3 and 1 in COOH. So this is the formula of ethanoic acid, CH3, COOH, right? So now you have to react this ethanoic acid with the butanol, right? So when you will react the ethanoic acid with the butanol, so ethanoic acid is your CH3COOH, as we have just suggested its name right now. And if you look at the butanol, so I have already written the formula C4H9OH. This is the formula for butanol. So if you will combine both the carboxylic acid and alcohol, so then ester would be formed. So how the ester is formed? That the OH from the carboxylic group and the hydrogen from the alcoholic group, they will be removed and combined together to form the water. So I am writing minus H2O, the water will be formed. And how the ester formation will take place? The ester formation will take place in a way that this is what it is left, CH3CO. So CH3CO. Now this oxygen will combine with, right? So because the hydrogen is removed from this side, so valency of oxygen is now unfulfilled. So this oxygen has to make the bond with the oxygen of the carboxylic acid. So you are getting this oxygen, and with the oxygen, what it is written, C4H9. So you will write C4H9, right? So this is the ester which will be formed over here, which is the ester B. So ester B is CH3COO C4H9, right? But in the question, it was asking you to state the name of an ester. So if I want to name this ester, so how I would name this as ester? So the naming starts from here, right? It's C4H9. So if you look at C4H9, so C4H9 is an alkyl radical which is having a name butyl, right? And now look at the left hand side. In left hand side, count the carbon atoms. We have 2 carbon atoms. So for 2 carbon atoms, we use the suffix, we use the prefix eth. So it would be ethan and O8. So butyl ethanoate is the complete name of an ester which would be formed. So you have to write the name of an ester which is butyl ethanoate. So this is the answer for this question. Now similarly, in part C, it is asking state the name of the compound C. So now in this diagram, if we see where is the compound C, over here it is the compound C, right? So for the compound C, they are asking you to name the compound C, right? So compound C is in carboxylic acid, right? So just count the number of carbon atoms. How many carbon atoms are there? 1 of COOH, 1, 2, 3, 4. So there are 4 carbon atoms. So for 4 carbon atoms, we use the prefix but. So carboxylic acid would be your butanoic acid, right? Now deduce the molecular formula of the compound C. Now look at the compound C. Molecular formula means you have to count the total carbon atoms. How many carbon atoms are there? 4 carbon atoms. So in the molecular formula, I would write C4. Now in the compound C, count the total hydrogens. 1, 2, 3, 4, 5, 6, 7 and 8. Right? So total there are 8 hydrogens. So C4H8, and now only one oxygen is 2 oxygens are there, 1 and 2. So C4H8O2. This is the molecular formula for the compound C, which was your butanoic acid. I hope that is clear to everyone. Now coming to the part D, it is saying state the name and the formula of the compound D. Now if you go to the compound D, right, this is the compound D, and compound D is basically being formed when you are reacting this butanoic acid with the sodium carbonate, right? This is your butanoic acid, and you are reacting this butanoic acid with sodium carbonate, which is Na2CO3. So as you all know that this is a reaction of acid with the carbonate, right? So whenever the acid and carbonate reacts together, so what products are formed? You have a study in the chapter of the acid and bases. So acid and carbonate reacts together to form a salt plus carbon dioxide gas plus water H2O. So 3 products are formed, and here you can see 3 options are given. D, obviously D would be your salt which would be formed, right? So D is a salt. A gas E is formed, so gas E, you know, carbon dioxide, and the liquid F. So liquid F is this one, which is your water. So if you look at the part E first, so in the part E they were asking state the formula of the gas E and the liquid F. So if you look at this diagram again, so the gas E was carbon dioxide CO2 and the liquid F was water H2O. So here I would write, first solve this one, CO2 and liquid F was H2O. Now coming back to the part D again, in the part D they are asking you to state the name and the formula of the compound D. Now for the compound D, what you are doing, you are reacting the butanoic acid with Na2CO3. Butanoic acid with Na2CO3. So butanoic acid is like this, CH3, CH2, CH2, COOH, right? I have made this formula condensed, right? This was the formula of butanoic acid. Here you can see it again. 4 carbon atom is having 3 hydrogens, so CH3, CH2, CH2 and COOH. So I have written this formula in the condensed form. So this is the formula of butanoic acid, and they are asking you to react this butanoic acid with the sodium carbonate Na2CO3. So what will happen? A salt will be formed along with the carbon dioxide and water. So you know that the carbon dioxide and water are the byproducts. Now you have to suggest the salt which would be formed. Now how this salt is formed, as we all know that this carboxylic acid is a weak acid, right? And we know that the acids remove the hydrogen, they form the hydrogen ion. So in this carboxylic acid, from where the hydrogen ion is removed? From this H, right, which is present in COOH. So this hydrogen is removed by the carboxylic acid, and that's why they show the acidic property. So when you will remove this hydrogen, right, so the salt will be formed in a way that this sodium would be replacing the hydrogen. The sodium would be replacing the hydrogen to make a salt, right? So, but it's not very simple. You have to first check the valency of sodium from the periodic table, right? So from this carboxylic acid, this group will be formed, CH3, CH2, CH2, COO, right? So you'll be getting CH3, CH3, CH2, CH2, COO, right? So hydrogen is removed, and instead of hydrogen, the sodium would be replaced in order to make a salt, right? So this is having a negative charge because the hydrogen is removed, and this would be replaced by the sodium. So sodium, look at the periodic table, sodium is having a charge of +1 because it is in group 1. So +1 and -1 would cancel, and obviously you would be getting a formula CH3, CH2, COO, Na. So this is the formula of the salt which you will be getting, right? Now they were also asking the name of this salt which is being formed. So how are you going to name? The naming of this salt would be similar to the naming of an ester, right? When you were naming an ester, you started from the group which is attached with COO. So after COO, what is there? Sodium is there. So first of all, you will write sodium, and then look on the left hand side how many carbon atoms are there. 1, 2, 3, 4. So for 4 carbon atoms, what we use? Butanoate, right? Sodium butanoate. It is just similar to the naming of an ester, right? In an ester also we write ethanoate, right, by counting the carbon atoms on the left hand side of the carbonyl group. So over here we are also doing the same. Okay, we are counting the carbon atoms along with the carbonyl group 1, 2, 3, 4. So butanoate. I hope that is clear to everyone. Now coming to the part F, draw the structural formula of an ester G. So here it is an ester G. So you are reacting the butanoic acid with the ethanol now, right? So butanoic acid with the ethanol. So in the similar way you will do it. Butanoic acid you will take CH3, CH2, CH2, COOH, and you are reacting this butanoic acid with the ethanol CH3, CH2OH. It's written over here, CH3, CH2OH. So it would be CH3, CH2OH. So as I have told you earlier as well, okay, if you want to make an ester, so how are you going to make an ester? You will remove the OH from the carboxylic acid group, and from the alcohol. From the alcohol you have to remove the hydrogen part. So this hydrogen would be removed from the alcohol. So this H and OH will combine to form water, right? And once this H and OH will be removed, so if you remove the OH from this side, and if you remove the hydrogen from this side, because they are removing in order to form water, so what will happen? This O will now make a bond with this O of the carboxylic acid from which the OH is being removed. So what final result you will be getting? I am writing this part of butanoic acid, CH3, CH2, CH2, CO. Now this oxygen will be joined with the oxygen of the alcohol, right? So in the alcohol we have this oxygen, and beside oxygen what we have? CH2, CH3. Okay, so this is the final answer. So this is the ester which will be formed, and this is the structure formula of an ester. So you just have to write this answer for this question. So I hope this question is clear to everyone. Alright, now coming on to this question. Now in this question it is saying that name the type of the linkage that bond repeats to one another in this polymer. Now if you look at the linkage, right, this question is related to the polymerization. Okay, so they are asking you to name the linkage that the bond repeats the unit to one another in this polymer. So this is your monomer which is repeating n times, right? So this monomer is having two groups. One is the OH alcoholic group, and the another group is your carboxylic acid group, C double bond O and OH group. So when this monomer will combine to form a long chain of polymer, so how the polymer would be formed? If I redraw this monomer again over here one more time like this. So how these two monomers will join? These two monomers will join in a way that the OH will be removed from the carboxylic group of the one monomer, the first monomer, and from the second monomer. And from the second monomer, you have to remove the hydrogen from the OH group. Okay. There are two groups in the monomer. One is the carboxylic group and one is the alcoholic group. Right, so from the first monomer you have to remove the OH from the carboxylic group, and from the second monomer you have to remove the hydrogen from the alcoholic group, which is the OH. Right, so remove this hydrogen and OH. So what will happen? This O will join with this carbon atom. Right, so when you will join this O with the carbon atom, so what would be the final result? The final result would be like this. I am redrawing this monomer again. So this is OH, C double bond O, and then what you have this box, and from this box you were having OH, but hydrogen is removed now, and instead of the hydrogen, this O is making the bond with this C double bond O of the first monomer. Okay, so I am making a bond over here, C double bond O, and then in the first monomer you have a box, and then you have again the OH group. Okay, alright, so if you look at the polymer, so what group you are getting? You are getting this linkage, right? This is the linkage which is being formed, and when you look at this linkage, so this is your ester linkage. So they were asking you to name the linkage. So this is your ester linkage which would be formed multiple times when you were making the polymer from this monomer. Okay, now coming to the part 2, explain how the equation shows that the polymer is made by condensation reaction. So as you all know that there are two types of polymerization, addition polymerization and condensation polymerization. So the difference is that in condensation polymerization, along with the polymer, this is your polymer, so along with the polymer a byproduct is formed, and that is the water molecule, which is a byproduct. While when we talk about the addition polymerization, so addition polymerization, only the polymer is formed and the water molecule is not formed. in the addition polymerization, right? So as you can see in the equation, the water is being formed, so that's why we are calling it a condensation polymerization, right? So here we're going to write the answer that along with the polymer, water is also formed. That's why we are calling it a condensation polymer or a condensation reaction. Now coming to the part B, it is saying a polymer contains 10.8% carbon, 17.1% fluorine and 72.1% bromine by mass. Calculate the empirical formula. So as you all know that for empirical formula we have two steps. The first step is to divide the percentage, whatever percentage is given, with the AR. So carbon's percentage is 10.8 divided by 12, right? Similarly, for the fluorine also you will do the same. Percentage of fluorine which is given in the question divided by AR of fluorine, and it's 17.1 divided by fluorine's AR is 19 if you look at the periodic table. And similarly, if you check for bromine, so percentage of bromine divided by AR of bromine, and the percentage of bromine right now is given 72.1 divided by the AR of bromine, which is 80. Okay, now you have to solve it in the calculator. 10.8 divided by 12, you will be getting 0.9. If you divide 17.1 by 19, you are getting 0.9 again, and 72.1 divided by 80, again you are getting 0.9, right? So this was the first step. And in the second step, what we do, whatever the answer of carbon is coming in the first step, which is 0.9, you have to divide with the smallest answer of the first step. And when you compare all the answers of the step 1, all are similar, 0.9. So the smallest answer is also 0.9. So divided by the smallest value, you will be getting 1. Similar for the fluorine, the answer of fluorine is 0.9 divided by the smallest value, which is also 0.9, 1. And if we calculate the atomic ratio of bromine, so the answer of bromine is 0.9 in the first step, the smallest answer is 0.9, again you are getting 1. So these are the atomic ratios, and all the atomic ratios you are getting 1. So this is showing the empirical formula C1, F1 and Br1. So this is the final answer for the empirical formula of the polymer which is given in the question. So I hope that is clear to everyone. So these were some of the questions which were related to the organic chemistry. So I hope you like this video. So meet you in the next video with a new topic and new set of questions. Up till then, take care and Allah Hafiz.